Okay, in this question, what have we been asked to do? This is a relative atomic mass question, and we've been presented a sample of lithium, and we've been asked, well, what's the relative atomic mass of this particular sample? In order to calculate the relative atomic mass, what we need to look at the isotopic masses. So we need to look at the relative isotopic masses of each, and we also need to look at the percentage abundances. All of this has been provided in the question, and we've been asked specifically to give our answer, if it does have decimals, to 2 decimal places. Okay, so first of all, what we've got these the relative isotopic masses, and we've got the respective percentage abundances as well. Now, in order to answer the question, one of the first steps we need to do is we need to multiply each of the relative isotopic masses with their respective percentage abundances, and then we need to sum what we get, right? So in this case, for 6Li, we know it's 38.32. For 7Li, we know it's 15.49, and for 8Li, we know it's 46.19. Right? What we need to do is multiply 6 by 38.32, 7 by 15 etc. Right? So and as I said, we need to actually sum these. So we're going to take the first one and we're going to add it to 7 multiplied by 15.49. Add it to 8 multiplied by 46.19. And well, if you get a calculator and work that out, I mean, I invite you to have a go at that. What you're going to get is 707.87. Right? Now, what do we do with the 707.87? Right? Well, what we need to do is we need to divide it by the total percentage abundance, right? And sometimes the total percentage abundance might not be 100, right? So we do need to consider what is the actual total percentage abundance. So we need to actually add the percentage abundances to work out what the total is. So 38.32 plus 15.49 plus 46.19. Now, when you work that out, you will find that it does come to 100, right? So it comes to 100, 100% effectively, right? So this is quite a straightforward one in the sense that, therefore, what you need to do is divide. You need to divide the 707.87 just by 100. If it was a higher number or a lower number, we would use that number instead. But here it is 100, and from that we get 7.0787. Okay, so is this our answer or not? Well, we're close, but we do have to pay close attention to what the question actually asked us for. The question did not just ask us to calculate the relative atomic mass, but it asked us to calculate the relative atomic mass, and if it has decimals, give it to 2 decimal places. So in order to quote unquote get the correct answer as what was required, we still need to do the rounding to the correct decimal places. So in this case, it would be equals 7.0 8, right? So the 8 would be rounded up to then be 7.08. Now, do we have our answer now? Yes, we have our answer. So in this case, the relative atomic mass of lithium in this specific sample is 7.08.